Hello friends, today we are going to discuss about the Rankine cycle. Basically Rankine cycle. So let us discuss about the Rankine cycle. It is one of the cycle which is treated as a basic cycle for power plants. So we try to understand it with the help of TS diagram and block diagram of power plant. So in power plant, all of you have been aware that there are certain components which belongs to any thermal power plant. The first is boiler, second is turbine, third is condenser, fourth is pump, and these four essential components of any power plant. So this is the boiler, this is the turbine, this is the condenser, this is pump. Now guys, with the help of this block diagram of thermal power plant, we try to understand how the Rankine cycle works. So see, there are four different processes in Rankine cycle. In TS diagram, you know that these are the saturated line and this is saturated vapor, saturated liquid. Now what happened in the Rankine cycle, like this process 1, 2, 3, 4. Let us say this is process 1, this is process 2, this is process 3, this is 4, and this is 4 to 1. Now guys, you have to see over here, this is the Rankine cycle presentation on TS diagram with the help of this block diagram. So this process 1 to 2 happens over here. This is 1 to 2 happens in turbine. In turbine what happened? Isentropic expansion takes place, that is represented by 1 to 2. Since it is isentropic, so the straight line up to 2. 2 is the exit point of turbine, 1 is the inlet point of turbine. So 1 to 2 is the isentropic expansion process, means steam will be expanded in the turbine isentropically where entropy remains constant. Then 2 to 3 is the process happen in condenser. This process 2 to 3 would be constant heat rejection. So heat rejection process will be there during the 2 to 3 at condenser. So it is treated as constant pressure, that you have to be remembered. Now this 3 to 4, now the exhausted steam from the turbine goes to the condenser where it will becomes water by condensing and getting the cooling effect of supplied water from outside or any source. It may be cooling tower, that's like things. Now 3 to 4, this 3 to 4 is the pump work which are here. Now since in the condenser all the steam is condensed and becomes saturated water, that saturated water will be lifted by this pump and fed to the boiler. So this 3 to 4 process is treated as again isentropic compression of water. But since you know water is incompressible, so a very small amount of pressure will be rise, and small amount of pressure will be raised and pressurized water will be fed to the boiler where it is treated as a sensible water which will be required to heat up and convert into vapor. So 3 to 4 is the isentropic compression process which happens in the pump. Now 4 to 1, this 4 to 1 happens inside the boiler where sensible heating of water in 4 to 1. So 4 to this point, what happened? Boiler, since this water is having around certain temperature, might be possible it is 30 degree or 40 degree, which is fed to this pump, to this boiler. Now this, since this water is 30 to 40 degree approx, in general it is room temperature or more than that. So that since we want to convert that water into steam, so it should be reached at 200 degree. So the water which is fed by this pump will be heated through certain fuels like coal and whatever the fuel in that power plant, and that fuel will heat the water which is fed by this pump and raise its temperature up to 100 degree. So this point shows that saturated temperature of water which reached at 100 degree, and at 100 degree water started to vaporize and it becomes steam. So dry saturated steam will be the at the output of the boiler. So at the exit of boiler we will get the dry saturated steam. So this 4 to 1 process is completely a heat addition process where we are supplying the heat addition, and this is heat rejection. So this process 4 to 1 is completely heat supplied process which occurs in terms of sensible heating, and then latent heating is supplied by the the external source which is fuel, and the water will be converted into dry saturated steam, and that steam again enter to the turbine. Again it will expand isentropically, then it moves to the condenser. In condenser the whole exhausted steam will be condensed and all the steam becomes water. Now this saturated water, since this is the saturated liquid line, so 0.3 lie on this saturated line means what? This 0.3 shows the saturated water condition. Now that saturated water is extracted from this condenser by this pump and fed to the boiler. That happens in the process 3 to 4, and when pump fed the water to this boiler, that process is treated up to 4 to this point where sensible heating occurs in the boiler, and then at the exit of boiler it is represented by point 1 and steam becomes dry. So that's why this point is also in the dry saturated vapor line. So all these process 1 to 2, process 2 to 3, process 3 to 4, and then 4 to 1. These are the four different processes which constitute, which the Rankine cycle constitute with itself. So there are four processes that you have to be notice, that process 1 to 2, it is isentropic expansion. Then process 2 to 3, process 2 to 3 is constant pressure, the constant pressure condensation. And process 4 to 1, 3 to 4, process 3 to 4 is isentropic compression, or you can say pump work, since it is liquid. Now fourth is process 4 to 1, that is heat addition process. So this heat addition process occurs at constant pressure. So heat addition process. So this is the heat addition process at constant pressure in the boiler. Okay, so these are the different processes which are having which explain the Rankine cycle, how Rankine cycle works, and what are the different points and what are the different components, and this is known as the basic cycle for any thermal power plant. Okay guys, that's it.